Hello, good morning, welcome. Hi, here again. I thank you for coming back. I was here yesterday. I don't know that I have done recently 2 of these live streams, oh shoot, in a row, but this is
Coding Rainbow
with me and my friend, the keyboard that operates as a soundboard. Am I actually streaming live? Do you see me? Do you hear me? I don't see anything going on actively in the chat, so I could only assume that perhaps this is working. My name is Dan Schiffman. This is Coding Rainbow, episode 54. And I'm here again, this time on a Wednesday morning, July 27th. It's about 10:45 a.m. in New York City. It is another very hot day in New York City, although it is a little bit cooler than it was yesterday. Somebody yesterday suggested that I wear a different t-shirt. I'm wearing a different t-shirt today. Exciting events in Coding Rainbow. And, you know, much like Shark Week, this here on Coding Rainbow is Genetic Algorithm Week, which doesn't have as nice of a ring to it as Shark Week, but someone suggested Darwin Days or Evolution, every day or something. I don't know. But I do see that the chat is now live and active. I see that there are 16 people watching. People I imagine will be trickling in. If you happen to be watching this as an archive on YouTube, you can check this video's description where there will be links to time codes where certain things will happen in this video, as well as links to edited versions of some of the tutorials that I'm going to do in this morning's session.
So this is random, this is noise, Perlin noise that is, in the core random algorithm, the actual random
So that was just a little ditty known as the Perlin Noise song by F. Looper on SoundCloud. Okay, so I'm looking at the chat. Somebody, I think that I added some settings, by the way, in the chat to automatically block people who use certain language, and I think somebody got blocked automatically. So hopefully that isn't causing too much trouble. Okay, anyway, so I have a bunch of things I want to do today. It's Darwin Days here on Coding Rainbow, so I want to do some more stuff about genetic algorithms. I want to talk about interactive selection. I want to talk about doing something that is more of like an ecosystem simulation. I want to look at the traveling salesperson problem and how genetic algorithms can be a solution to that particular kind of problem. And then I want to look at, then I want to look at I want to talk about fitness functions, what makes a good or bad fitness function. And although maybe, there's no such thing as a bad fitness function, all fitness functions are nice fitness functions, just some perform a little bit better than others. And then I also want to talk about different strategies for selection. The strategy that I've been using in some of my examples involves this very large array with taking members of the population and putting them in the array many, many times and picking randomly. And I want to look at a comment that came in through GitHub with a different solution, and maybe we'll try to implement that solution. Also, oh, the camera went off already. 30 minutes has passed since I turned this camera on. I wonder if this one will go off too. I'll just cycle it. I also want to do a coding challenge that I think I will start with on Phyllotaxis, because one of the things I love in life is algorithmic botany. So let me go here for a second to a website, which I believe is, I'm just going to actually Google Phyllotaxis. And, oh, there's so much has come up. But I want to go to this link here. Chapter 4, Phyllotaxis from algorithmicbotany.org. So, what I want to look at is this particular pattern and this particular formula, which, you'll start to look at reading these papers, this kind of thing looks like, oh my goodness, there's a square root sign and some Greek letters, and I don't want to deal with that. This is actually incredibly simple. So one of my jobs here on Coding Rainbow is to take things that sometimes look like you want to put them away and try to make them more accessible and simple, and we can make some beautiful patterns. If you like sunflowers, and boy do I like sunflowers, if you like sunflowers, you're on your way today to making beautiful rainbow-colored sunflowers. So I think that that's what I'm going to begin with. I'm going to dispatch with some of the usual business that I do. I could show you the GitHub repository where you could suggest topics. I could show you where you could get some t-shirts, all that sort of stuff. If you're looking for that, ask in the chat. I'm sure somebody will help you. Somebody's asking, what did I drink? That is iced coffee. I do not particularly like iced coffee, but it is just so hot in New York that drinking hot coffee, not really good for today. Oh, by the way, sometimes I like to make a nice thumbnail for a video and I feel like a bunch of sunflowers. There's my thumbnail for this video. Okay, so let's see. Let's put on some music.
So this is random.
And let me get set up. I think we'll do the Phyllotaxis example in P5. I'm going to not use CodePen. I was using CodePen yesterday as some experiments, but I think... will this come up? No. I'm just going to go back to my old-timey Atom editor. And I'm going to now... yesterday I was working on overloading. So let's make a new folder here and call it Phyllotaxis. And let's open this with the Atom editor. Okay, there we go. And let's take out all the code. And let's go to terminal. Now I'm going to run a local server. Go to the desktop and run my Python local server. By the way, I have this idea. I don't know if you've heard. There's this thing called Pokemon Go, which is quite popular these days. And I kind of wanted to stop everything and see if I could scrape the Pokemon Go server and make a little visualization of Pokemons everywhere, because I know that would really drive those YouTube views. But then I was thinking, oh, there's traveling salesperson problem. You could actually think about Pokemon Go as a kind of traveling salesperson scenario where you're in the park outside in the woods and there's all the Pokemon and you need to figure out the most efficient path through all of them. Anyway, something I'm thinking about. Local host. Let's look for Phyllotaxis. Let's get this going here. And let's get the editor back up, and let me add a setup function. Oh. Let me add a draw function. You guys tired of this song yet? And I think I'm just about ready to do, whoa! There we go, some Phyllotaxis. Do you play Pokemon Go? For the first time, I played Pokemon Go last evening in Central Park. Last evening, meaning yesterday evening, I caught 7 Pokemon. I played with my 8-year-old son. He really wanted to play, and I was like, no, I don't want to deal with this thing. We're always going to be on the phone, and now we're walking. So we're going to try it. We're only going to do it in the park, not while crossing streets. And we went on a nice hike. We went through the North Woods. I love the North Woods of Central Park. But the thing is, what I like to do in the North Woods of Central Park is look for birds. I'm very interested in birds. We go bird watching and on hikes. Pokemon, it's interesting, but I kind of like the real life birds. Okay, I'm sure that's what you all were hoping that I would discuss today on this Coding Rainbow. Let's see how many people we have watching. 37 people. That's nice. Thank you all for being here. And I am ready to tackle Phyllotaxis. So I've got the Algorithmic Botany Chapter from algorithmbotany.org. I got my pictures of my sunflowers, and I got this sketch open and ready to go. Okay, so look at this. It is exactly 9 minutes and 50 seconds into this live stream. And I'm about to do a coding challenge All of you who thought, oh, it's going to start at 10:45 and I'll wait till around 11:15, because usually there's like a half an hour of like bumbling around and like tripping over things and like explaining where the GitHub repository is. And here we are, Phyllotaxis. Here we go, record time. I know, Dominic. Okay, here we go. Okay, so let's just do it. What should I start as my opening screen? This is a nice opening screen. Okay, fill our taxes, yeah. Okay, I got my, by the way, I feel like this fan that's pointing at me has a kind of Phyllotaxis. One thing I really want to be able to do is I want to have, right now I have, these are the different camera views I have. I have, shoot, I have this camera view that you're seeing. I have the whiteboard, and then I also have over here, I don't have a shortcut, I have just the green screen view, which is me, hi. I want to be able to just press a button and then have you see what my phone camera sees, so I could show you things around in this room. But at the moment, I don't have that. Okay, back to here. Let's get my soundboard. I don't think that I'm going to bother with the whiteboard for this one. I think it's interesting as that might be. I don't think it's necessary. Okay, here we go. Yes, I will begin now. Hello and welcome to another coding challenge. In this coding challenge, I'm going to continue off of a topic that I've done in a lot of other coding challenges known as algorithmic botany. One of the things I happen to love in life are sunflowers. And if you look at the center of the sunflower, there's this beautiful kind of spiral pattern. It exhibits the properties of the golden ratio and the Fibonacci sequence and all this sort of mathematical stuff. And another term for this is Phyllotaxis. So if you go to the Algorithmic Botany website, you will find a free online PDF book called Algorithmic Botany, and chapter 4 is all about Phyllotaxis. And you could read more about the background of this, but what I want to look at in particular is really just how to program this pattern. And actually all of it is right here. Right here in this paper. This is, I'm going to move my mouse here. This is exactly all of the math we need to program Phyllotaxis. Now you might look at this and think, oh, there's a Greek letter, there's a degree sign, a square root. I don't really want to deal with this, but I'm here to tell you this is actually quite simple and we're going to be able to do this quite easily. There's really only 3 variables that we need. Actually, I guess there's 4. Whatever the number of variables there are, here's something that's really important, n. We're going to draw a whole bunch of circles on the screen, and each one of those circles will have a number n. There'll be the 0 circle, the 1 circle, the 2 circle, the 3 circle, the 4 circle. So that's n. N is just a number that's incrementing up. The other thing that's really key is this value c. That's kind of a scaling factor. Do I want my Phyllotaxis flower pattern to be kind of stretched out or compressed? And then we're going to use both n and c to calculate an angle and a radius. And time out. I think that I do want to use the whiteboard. So this will get edited. I'm going to switch to the whiteboard in a second. Hello, I'm over here now. I got to turn a light on over here. I lost my rhythm there. This Phyllotaxis really should be something that I don't need to stop in the middle of, but I just did. Turn this fan on me here, turn this light on, and this will get edited together. Okay, well, let's come back and here we go. Oh, thank you, Hazem, for pointing out that phyllo means plant and taxis means motion. You know what? I'm going to start this whole thing over. Because I realize I think it would be nice to say a little bit about... You guys really must be tired of me. Let's look on Wikipedia for a second. Right, look at this. Comes from the ancient Greek phylon, meaning leaf, and taxis, meaning arrangement. Phyllotaxis spirals form a distinctive class of patterns in nature. Okay. So, okay, so I'm sorry, all of you live viewers, but some of you are joining late anyway, so you won't care. I'm gonna just do this tutorial one more time because I now recall that having the whiteboard for a little brief discussion of polar versus Cartesian coordinates is worth doing. Okay, here we go again. I'm gonna cycle the cameras. I'm feeling good. I haven't done any dancing today. Maybe you guys don't care.
So this is random, this is noise, Perlin noise that is, in the core
Gotta get
random
warmed up.
algorithm.
That was just me getting warmed up. Now I know it's 16 minutes, but 16 minutes is still pretty good.
I'm picking
Riley
numbers between
CL,
0 and
I am
10.
about to do
2, 7,
Phyllotaxis.
6, 1, 9, 4, 8.
I feel like they should have music in some of these videos, but anyway. Okay, here we go. Hello and welcome to another coding challenge. In this coding challenge, I am going to continue a series that I've been doing about algorithmic botany, one of my favorite topics. I'm here to tell you that if you like sunflowers, and I like sunflowers, then this is the video for you to watch, because what I want to talk about is a topic called Phyllotaxis, and I want to examine what Phyllotaxis is. I want to look at the math behind Phyllotaxis. Hopefully I'm pronouncing that right. And I want to create a nice, shiny, rainbow-colored Phyllotaxis example. So this is the Wikipedia page. Phyllotaxis, it comes from the ancient Greek. Phylon meaning leaf and taxis meaning arrangement. So it's a kind of spiral pattern that you see often in nature. It's connected to both the Fibonacci sequence, interesting thing to look up if you're not familiar with, and also the golden ratio. So the reference that I'm going to use is from this Algorithmic Botany, algorithmicbotany.org, from the University of Calgary website. There's a free PDF book. The math for everything I'm going to do is right here in this paper in chapter 4 of this book. And you look at this and you think, Greek letters and square roots and all that sort of stuff. But I'm here to tell you this is actually going to be something quite simple. So what I want to do is I want to rewrite those formulas. My soundboard went off by accident. I want to rewrite those formulas over here. I'm going to say phi, or phi, I can never remember, equals n times 137.5 degrees. This is a very, very special angle. Hearts and stars for this angle, 137.5 degrees. One of my favorite angles. Everybody should have a favorite angle in their life, I think. And then also I want to say r equals c times the square root of n. So you can see, this is all we need. So why, in the first place, do we need an r and an angle? Well, this is why. This is a coordinate space, a Cartesian coordinate space, with an x-axis and a y-axis. And we're going to plot every point in this spiral pattern based on an x value and a y value. So this is a point, it's some x and y point. However, what the Phyllotaxis math is going to give us is not an x and a y, but a radius and an angle. The radius being the distance from 0, 0, that's r, and the angle being the direction. So you're going to see like this spiral pattern come out. We're going to draw all these circles, each with a different radius that's either growing, and an angle that's incrementing. So we need to, but in P5 or processing or whatever programming environment you might use, I'm going to say like ellipse. I want to draw a circle at a given x and y. So what I need to be able to do is convert the radius and the angle to an x and a y. And how do I do that? I use something called polar to Cartesian coordinate transformation. I know that sounds kind of fancy, but basically I need a formula to go from my r and theta r and phi or theta or phi or whatever angle, r and angle, to x and y. And the formula for that actually just uses cosine. By the way, if you say cosine of this angle, it equals cosine of this angle equals adjacent over hypotenuse, x divided by r. Rx equals r times cosine of that angle, and y equals r times sine of that angle. We do the same thing with sine. So these formulas you're going to see in our code, and these formulas you're going to see in the code. Now this looks a little weird. The only thing here is really, the only thing, we're calculating r and the angle in order to get the x and the y, and in order to do that, we need to have an n and a c. What is n? N is, we're going to make a whole lot of dots for this Phyllotaxis pattern. And n is the number of the dot. Is it dot number 0, dot number 1, dot number 2, dot number 3, dot number 4? And c is a number for a scaling pattern. So you'll see that in a bit. Let's start to write some actual code. So I'm going to come back over here. And here we go. I'm going to come back to the code. I haven't actually come to the code yet. So let's just look. This is some P5JS code. It's running here in the browser. It does nothing but draw a blank canvas. But I'm going to create a variable, n, which equals 0. And I'm going to say n++, right? This is the first thing that I'm doing. Because each frame, and actually I want to draw my background in setup. Each frame I'm going to draw a new dot. And how am I going to draw that dot? I'm going to say angle equals, what was the formula again? N times 137.5. So n times 137.5. And the radius equals what? C times the square root of n. So we need to come up with what c is. Let's make up a number for right now. Let's make up a number, 2. I know, we're going to play with that number and we're going to see a bunch of different variety of results. Okay, so now that we have a and r being calculated, we can also remember now all we need are these two formulas to calculate x and y. So now I'm going to say var x equals r times cosine of that angle, var y equals r times sine of that angle. And then also, the thing is, I want everything to be drawn relative to the center of the window. So I'm also going to add width divided by 2 and add height divided by 2. That's just to take, because if you look at my diagram over here, I'm thinking about everything as calculated relative to an origin point, but in a computer graphics window, the origin point is the top left, and so I want to shift everything over. Okay, so now I'm just going to say ellipse x comma y, and I don't know, I'll make the ellipse 8 pixels or whatever, and I'm going to just say fill 255, and then we're going to run this program. I don't know why I'm condensing all the code, so no white space. Here we go. Let's run it, see what happens. Hey, look, that looks pretty good. Something's happened in here. Oh, wait, I think we finished. I think we did this already. Look, that kind of looks like a cool little spiral pattern. Well, let me show you some things. First of all, I'm going to just expand C for a second. Whoa, that's way too much. There we go. So, well, okay, no, this is not. Never mind. Trying to live code, that's not going to work. Let's make C a little bit bigger. Actually, I'm going to make it a lot bigger just for a second. Show you. I'm going to make it 20. You can see what C is doing is it's actually sort of a scaling factor. So how much is that radius changing, right? You can see here the radius is equal to the square root of the number times C. So if I'm drawing my circles at 8 pixels, with a diameter of 8 pixels, let's try making that C actually just something like 4. And you can see, we can start to sort of see that pattern. Let me make the circles a little bit smaller. Let me just say no stroke. Also, maybe and then we can run this again, and we can start to see there's that Phyllotaxis spiral pattern. There it is. Beautiful. There we go. In a way, I'm kind of done right now. I could sort of play with the scaling factor. I could actually play with the angle as well. And if we go back and looked at this paper, you'll see down here, like, oh, look at this. Here are some different kinds of patterns we could get if we kind of futz with the angle. This one here has an angle of 137.3. Not my favorite angle, but a perfectly reasonable angle. So let's run this and see what we get. And you can see how what kind of spiral pattern we get now, which is kind of interesting in and of itself. The other thing we could start to think about what we might do is how we might color the dots in a more interesting way. So one thing that I could do here is just use HSB color. So I'm going to oh, do you know what? I don't think this is right. I think this whole time I'm getting something sort of vaguely interesting, but I think that my angle mode, I don't think this is the exact Phyllotaxis spiral pattern, because I believe the default angle mode of P5 is radians. And really what this number is in degrees. So I need to change the angle mode to degrees. I don't know, can you tell? Yeah, this is a little bit different and actually more correct. So I think earlier in this video, my Phyllotaxis pattern was a little bit off, but now you can see I'm kind of getting that beautiful, more perfect pattern. And the reason why I noticed it is because I think when I went to 137.3, it didn't match up exactly with what was in that paper, but now this is matched. I can see that this pattern is exactly what's there. So let me go back to now what I was thinking. The reason why I thought of this is because I want to change the color mode to HSB, meaning when I create a color, I want to make it by its hue, its saturation, and its brightness. So if I were to say something like fill 100, 255, 255, then I'm getting a sort of green color for all of my dots in the pattern. And if I were to say 200, I'm getting a nice blue because that number is a hue between 0 and 255. So I could say something like, I don't know, just make it the angle modulus 255, and actually that should be modulus 256. Modulus being a way to cycle back to 0. So 256 modulus 256 is 0, and 257 modulus 256 is 1. So if I do this, you can see like, look at that. I get kind of a different sort of spirally hue for every single based on what the angle is. I could actually use n might also make sense just to do the actual number. So you can see now the number on the dot is controlling the color. I could actually do something kind of interesting, which I think is angle minus radius we might try. I think would be kind of interesting. The difference between the angle and the radius. I don't know if this is going to, whoops. Oh, it's just called A. And I guess I'll say modulus 255 there as well. Whoops, oops, and I'm missing a parentheses. Here we go. This is kind of, you can see how the, you can see kind of where the hue is kind of traveling around in this spiral pattern. So there's all sorts of possible ways you can think about how you might create the color. Another thing you could do is I could change the size of these circles based on where they are in the pattern. They could be smaller in the middle, larger to the outside. All sorts of things. So here we are. I've got a nice thumbnail here for this video. I've made a Phyllotaxis pattern. I would love for you guys to go take this code that I'll release with this video, scroll down, read more of this paper. Can you make a nice sunflower pattern? Can you expand on this? What types of things might you do? Make some experiments, make some beautiful Phyllotaxis, and I will see you in another coding challenge in the future. Thanks very much for watching. Okay, Leon in the chat writes, check if n is prime and draw an Ulam spiral really quick. That's kind of an interesting idea to do. But I think I'm going to leave that for another time. Could you increase n by less than 1? It's an interesting idea. And by the way, I should have played with this value a little more, like 7. And then I could have played with the size more. You know, what if I do something like this? Actually have the, you can see them get bigger and bigger as you go to the outside. Ooh, that's kind of nice. And I could do like, I could give it a little bit of alpha. So they like blend on top of each other. Oh, that didn't work. How come I'm not getting alpha? Fill, 255, 255. Oh, you know, no, they should be getting alpha. What am I doing wrong that I'm not seeing any alpha? That's weird. Oh, am I drawing over top of you then, like multiple times? Yeah. Color mode should still, alpha should still work. You're right though, it's not. Why is that not working? Look at it work there perfectly when color mode is not HSB. Huh. That's what I was planning to see. All right, this is interesting. Have we found a P5 bug? Let's be more explicit about the ranges. Ah, that's working now. So that's working. Interesting. So what was the default value? Yeah, without specifying. Is it between 0 and 1? So I think we found a bug, unless it's supposed to behave this way. If somebody wants to file a GitHub page, this is quite a nice, beautiful pattern, by the way. I'm really quite enjoying this pattern. So many beautiful rainbow patterns today. If anyone wants to file this as a bug on P5.js, I'm not 100% sure, but to me, this is what my sense. Wait, let me do this again. This has got to be a bug, right? Because if the default range of hue, saturation, and brightness is between 0 and 255, why should the default range of alpha suddenly be between 0 and 1? That's not how it works in RGB mode. So I believe that is a bug. So someone can feel free to, what I would suggest, actually let's do this. Did somebody file it already? I like to do these kind of things live. Let's actually file this as a bug. Okay? So what I want to do, so this is how to file a bug. Maybe I'll make this a separate contributing to P5.js. I'm trying to decide if it makes sense to edit this out as a video. Whatever. Let's just do this here on the live. It doesn't. It can be edited out as a video. I'm gonna do it as if it could be edited out as a video. We could decide later if it should be. Okay. So hold on. I want to save the Phyllotaxis because I don't want to lose that. Can I do reveal in Finder here? Show in Finder. Phyllotaxis and P5 HSB bug. And I want to open this up. Okay. What about the second and third argument? That's a good point. I should check. I don't believe so, though, because... So I'm going to check all this. That's what I'm going to do right now. Okay. Hello, welcome to a video about filing a bug in P5.js. I think that I have found a bug. I'm going to test a few things in this particular video and then file it as a bug report on GitHub, and you can kind of watch me do this and feel more confident to file your own bug reports. I was working on an example with Phyllotaxis patterns and HSB, hue, saturation, brightness values, and I think I have found a bug. So what I want to do is just sort of clear out all my code for a second, and I'm just going to create a canvas that's 400 by 400. I'm going to say background 0. Okay? So there's nothing there. What I want to do is I want to say fill. I'm going to make a red color. And I'm going to draw an ellipse that's just at 100, 100. That's like 40, comma 40. And then I want to draw another ellipse that's at, let me think about this. Just make the math easier on myself. That's at 125, 50, 50. So what I want to see is 2 circles overlapping. There we go. And let's say no stroke. And then what I want to do is add some alpha. So the default range for transparency, just like the default range for red, green, and blue, is between 0 and 255. So if I do this, we should see exactly, that's what I expect to see. They're transparent. We see a little bit going on. Now, just to really sort of prove this point, let's have a separate fill. And do that, and make this color blue, because what do we get when we mix red and blue? We get kind of a nice purple, one of my favorite colors. Okay, so this is working as expected. So I'm going to comment this out, and actually I don't need to, and yeah, I'm going to, just to be completely crazy about this, and I'm going to comment it back in, and I'm now going to go to, I'm going to say color mode RGB. So the default color mode should have been RGB. And it still works exactly the same way. I'm going to change the color mode now to HSB. Now we should see everything should go out of whack. And I only see like one white circle. So a lot of craziness has happened, and that makes sense. So what I want to do here is now that I'm using hue, saturation, brightness, I want to just have the saturation and brightness be all the way up. And I want to have 2 different hues. I'm going to pick like 100 and 200. I don't know what those values will be. It'll be a green and a blue, or a yellow and an orange. So we should see, okay, so I got kind of a greenish color and a blue color, but I've lost the transparency. The reason why is because now I've got to say 0.5. And we can see that now I've got the transparency back. But I don't believe that the range for transparency, do they really? Okay, so someone's telling me in the chat, color mode, let's use the HS, oh, by default the color mode is 360, 100, 100. Okay, so I've now gone off the deep end here. I've been explaining away this like total logic that I haven't even looked at so now let's check the reference. Color mode HSB, color mode P5JS. So let me look at the reference. And I'm sure this was discussed and I kind of just missed it because I'm a doofus. I got to check the reference. Let's take a look. Okay. I'm starting to see what's going on here. By default, this is color mode HSB 360, 100, 100, comma 1. What's the expression? Read the manual? Yeah, that's what I should have done. Okay, never mind. It was nice that I went on this little thought experiment. Nobody filed that bug. If anybody, let's check to make sure if anybody filed that bug, I will take all the blame for it. Let's check the issues. Doesn't look like the last bug was open 3 days ago, so we're good unless anybody closed it already. Nope. Okay, so sorry for that little digression. At least I didn't forget this dot, this dot, this dot, this dot's on. Never forget this dot. Okay. All right, so that was good. Anyway, back to the Phyllotaxis example. I was playing around with making it, let's just go back to that for a second so I can feel a little better about myself. So actually, I was messing around with color. That's what it should be. Let's make the size the square root of n. Ooh, this seems like it'll be exciting. And the alpha, well, it was way too little. Let's just give it a little bit of alpha. So this is kind of nice if I make the size also the square root. Oh, look, I lost all my alpha. And I also like having it being, I like the A minus R solution. And let's have 0.5. Okay, this is what you missed. There, this is the pattern. Actually, you know, I should have referenced this, but I was looking at, I want to add one thing to this example, just while we're here. I was looking at Mike, so there's a really nice, Mike Bostock, who is the creator of D3, has a Phyllotaxis example. Oh, this is actually from jasondavies.com. You can see the same exact formulas there. And beautiful version by Mike Bostock. So I like this one. You can see what's nice about this is the whole thing is also kind of like spinning. Boy, it's going really, really fast too. So wow, look at this all close to each other with like a really nice rainbow. Let's try to like get a little closer to this with the example. So one thing that I need to do is, because I am using canvas drawing and not SVG, what I want to do is actually, what I'm going to need to do is create an array of points. And I'm going to, oh, I know what I can do. I'll just do the calculation. So what I want to do instead of drawing just one, so in other words, here's the issue. If I put background here and draw, whoops, that's not my code, this is my code. You can see that I'm only getting one at a time because I'm erasing the background every time. But I could add a loop. Var I equals 0, I is less than n, I plus plus. So I'm going to calculate and draw all of the circles all the way up to n each time. And so I need to replace n with I. And where else am I using n? Here and here. And actually, I think I'll just use a fixed size now and run this. So now you can see that's working again. The nice thing about doing it this way is that I can do a couple things. One is, and let's take this out for a second. One is I can use translate. So let me say translate width divided by 2, height divided by 2. And I can take out this extra offset. And I can rotate. Let's just rotate by n. So now you can see the whole thing spinning. Ooh, that's kind of nice. I'm going to hypnotize. Let's hypnotize everybody. It's spinning kind of fast. So let's spin it by n times 0.3. And now let's think about the sizing. So let me make the size smaller and the scaling factor a little bit smaller. And the scaling factor even smaller. Yeah, there we go. So now you can see something. Now, the thing is it's quite nice and beautiful, but it's happening much slower. It's also a little bit too tightly packed. So one thing that I could do is I could increase n by like 5 each frame. And what you'll notice is it looks like, there we go. So that looks a little bit more like, this is much nicer. So first of all, look at the hue is just changing so drastically. Whereas if we go back to the Bostock example, I lost that one. You can see it was a much more gradual. So how might I do this? Let's think about this. Yeah, something like this maybe. I don't know what I'm doing actually. My A minus, I think my hue coloring, I could just look at Mike Bostock's code. Let's look at Mike Bostock's code. Perlin noise hue, that's kind of an interesting idea. Oh boy, you guys have gotten me, yeah, this is kind of an interesting idea.
So this is random, this is noise, Perlin noise that is. In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, like I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I picked 9 a lot apparently. But with Perlin noise.
Okay, so I just added a little Perlin noise in here by like using n, which is always incrementing. Oh, no, but I want to use like n plus I. Or I just want to use I actually. So let's see what happens here. Now you can see I'm going to get sort of like values that are going to change based on Perlin noise. Oh, and actually what would be really cool is to have those change over time. So if I do n plus I, you're going to see like some color cycling stuff. Oh, I could do like a sine wave. Okay, I've gone, you guys can enjoy this on your own. And actually, this is, what I want to do is, let me do this properly. I'm going to say start equals 0. And I'm going to do start plus, this is what I meant to do, I times 0.1. So now what I'm going to get is, these are just values changing based on noise. And you can see there's actually, this is not tied to the pattern at all, independent. But what I might be interested in doing is actually using a sine. And let's say var the hue equals sine of this, start plus I times 0.1. And then hue equals map that value, which has a range between -1 and 1 to 0 and 255. And then what I'm going to do, and let's look at this. So there should be a nice like sine wave of the color values. You can see it's like going to oscillate around. I guess it doesn't change that often, but that should be working. And then what I want to do is have start increase. Oh, I forgot that I'm in, angle mode degrees. Thank you. So this like times 0.1 is really quite unnecessary because I'm dealing with degrees. So there we go. Now you can see the colors are actually also changing and oscillating in the shape as well. But I think maybe there's so many of them that it's worth, and maybe I should go up a little, maybe go up a little bit more, faster. There you go. This is what I was there you go. I kind of crazy. All right. So I'm kind of going off the deep end here. So use 360 in map. In map. What did I? Because it's actually 360. No wonder it's not. The range isn't between 255. Thank you. No wonder I wasn't getting pinks and purples. I've been missing this all along. So there you go. I have now succeeded in possibly hypnotizing all of you with Phyllotaxis this morning. And this will be a good gift. Perhaps with some music. I'm going to hypnotize you. So people might be watching me from the other room. Okay, it's running kind of slow, but there you go. Okay, super rainbow, yes. Okay, so that is what I've got for you guys in terms of Phyllotaxis. Let me think here for a second. It's about 11:30. Oh, what do you guys think? A new version of Java is available. Should I install, yes or no? Close the door a little bit. Okay. 3D Phyllotaxis. Interesting. I'm sure we could come up with something. So here's some interesting ideas you could think about. I will let you guys pursue all of those on your own, and I'll come back another time for that.
Coding rainbow.
Oops. As always, I always forget the this dot. All right. No Java, abort. Okay. All right, so I think I'm going to return now to genetic algorithms. And I want to, let's come back and try to find some of my examples. What I'm going to do here, actually, is I need to go to my desktop and go in here, and I'm going to put that into this folder here, and here's the to be or not to be example. Okay, so there's a few things I want to discuss. I want to do a video about improved fitness function, and I'm going to do improved fitness function. I'm looking at the chat, sorry. I'm going to do improved fitness function and also different strategy for picking, a different strategy for selection. Okay. So somebody in the chat, Dalalalo21 asked, where can I find the Shakespeare Code? You can go to natureofcode.com, which, and if you do read now and chapter 9, there's a big explanation about this example. I made videos about it, but you're probably not going to go watch the videos right now. And then you can go to GitHub, the nature of code examples p5.js. So this particular URL right there. And I'm going to leave that URL up there while I come over here and erase the whiteboard. I'm erasing the whiteboard right now. That's why you can't see me. Okay. So here we are on I'm here. Back in Shark Week, Darwin Days or whatever this is, Genetic Algorithm Week. Let me go back. Let me close the Phyllotaxis stuff. And let me pull up this particular code example, and which is this one. Pull it up in Atom. And I'm going to go to DNA, and here, where's the fitness function? Okay. Close this out. Okay, so I just want to actually test something before I make the video. So put on some music for you guys. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot's on this dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot's on this dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot's on this dot, this dot, this dot. Never forget this dot. I feel like this is like a lot of.
So this is
Coding
this dot,
rainbow.
this dot, this.
I'm really not good at the soundboard thing.
Coding rainbow.
Ah.
Coding power.
Okay, great. So my theory about this is correct. The other thing I want to look up very quickly is I'm about to do something about fitness functions. And wait, I'm thinking. Fitness functions. Oh, right. The other thing I was going to do. You know what? I'm going to do these as two. It's weird. Like, so I have videos that are like 50 minutes long. I have some that are 5 minutes long, but that's life. Okay. All right. Here we go. So. Okay. Hello, welcome to another genetic algorithms video. In this video, I want to talk about an improved fitness function. Now, there are so many different ways you could improve a fitness function and ways that you could design and think about a fitness function. And I less mean this video to be like, here's one thing, but I just want to use this video as a way to start thinking about how this fitness function is your creative thing that you're creating and anything you could imagine you could possibly do with that function. So if you recall this particular example, which is a search problem, it's a simulation running a genetic algorithm to evolve the phrase to be or not to be. And every time I run this, it's typically taking somewhere between like 300 and 600 generations to get to the correct phrase. And you can see it took 554 generations. So let's talk about the fitness function. Let's talk about the fitness function. And the way if I were to graph that fitness function, right? This is the x-axis is the number of characters correct. Okay? So the more characters you get correct, the higher the fitness. Right? Yay! More characters correct, higher the fitness. And this works because I might have, in the case I might have a phrase that's like 20 characters long, and I have, 16 characters correct versus 17 characters correct. This has a higher fitness. It's going to be more likely to be picked as in the selection process to have its genetic information passed to the next generation. But there's a problem here. What if this phrase were not 20 characters long? But what if it were 2,000 or 200,000 or 2 million characters long? Let's think about the fitness values of certain random phrases. So one random phrase might have 391,263 characters correct. And another one might have 391,264 characters correct. Now this one is better than this one. And in fact, having just one more character correct, it's really a lot better than the other one. And we really want to make it more likely to have its genetic information passed down to the next generation. But if you take this value and divide it by 2 million, and you take this value and divide it by 2 million, the number you get from this value is only a tiny bit bigger than this one. So in other words, this value is only a tiny bit bigger than this value, but I really want that one that's a tiny bit higher to be much more likely to be picked because I want my evolution to happen efficiently and faster and all of that. So a simple way around this is to make the to make the fitness function exponential? What if I could have the number of the more characters you have correct, the higher your fitness is exponentially? And there are a variety of ways you could do this. I could say the fitness is 2 to the n, being n is the number of characters correct. I could take n squared or n to the 4th power. You know, I could probably come up with some other fancier math to do, but I just want to get you thinking that these are the types of issues that you want to think about. And in fact, let's go back to this program, and I'm going to go to the fitness function, which is here, right? And I'm just going to say, as a very simple thing, I'm going to say this dot fitness equals power this dot fitness squared. So this is me taking fitness to the 2nd power. And I could have just said this dot fitness times this dot fitness, but whatever. I'm doing this dot fitness squared. And now let's run it again. And you'll have to sort of trust in me at this point, but I ran this about 4 or 5 times, and it's solving it between about 300 and 600 generations. Let's run it again. We can play some music while we wait. There's no music. Oh, I didn't have to wait very long. 240. Let's run it again. Oh boy, it's taking a long time. Oh boy, this is not good. That was an anomaly. Run again. 217. That's pretty good. 236. You can see I've improved, and I could even go. I could go to the 4th power, right? 120. wrong button. Refreshed. 89. So you can see that exponential fitness function really has improved things. And so this is something you could consider. So you could also go back to the Smart Rockets example as an exercise. Find the Smart Rockets example that I made in the previous coding challenge and see if you could use that distance, the distance to the target, which is part of the fitness, and use an exponential function to see if you can make that particular evolution happen, more quickly or kind of work more efficiently. Okay, thanks for watching, and I'll see you in another video soon. Okay, everything's still working? You guys are quieter in the chat today. Maybe because I don't see Oliver today. Oliver's usually also correcting all of my mistakes. Okay, this is probably gonna be some very warm water at this point. Okay, that makes sense? What happens if it is raised to the 10th power? Well, at a certain point, it doesn't really matter in this particular example. But you can see, because there's not really a lot to this example, but you can see that it's hypnotized still. Okay. Was there a loud noise? The awesomeness atom? I forget that you guys are also 20 seconds behind me about in real time. Okay, so turn it up to 11. I have no idea. Because the chat is out of sync with what I'm doing, I'm often confused. Okay, so the other thing I want to do is use a different strategy. And I'm just looking for where this is. Oh no, in a population. I'm often confused. I want to use a different strategy for the mating pool. So let me come back over here. What time is it, by the way? It is 11:45. Have I only been doing this for an hour? I feel like I've accomplished so much in such a short period of time. That never happens. Okay, so let me erase the whiteboard here. Maybe what I should do, I wonder if I missed the deadline. Khan Academy has some competition for people to make videos, but anyway, I don't need to do that today. I don't know why I just thought of that. Okay, so the other thing I want to talk about is the mating pool strategy. And I want to do it in a different way using an accept-reject algorithm. Now let me see if I can find, let me find this example. I was just working on it, because I was rewriting the chapter in Nature of Code. Sorry, I'm thinking about this. Hold on. I know where it is. So I'm going to my processing examples, whoops, for a second. And I'm going to the introduction, and I'm looking for accept reject distribution. Was that really only an exercise? I guess so. So I just want this code for a second. And I'll open this up in processing. I haven't missed the deadline. What's the deadline? Oh, for the, yeah. For the Khan Academy thing, okay. Okay, so I want to look at this for a second. Okay. Let me make this a little bit bigger. Okay, hold on. Can I make this happen faster? Draw. Sorry, I need more music. I need more of a musical selection. I'm just doing something. Okay, perfect. Okay, so I want to. So this, okay, I'm just thinking here. Okay, so what I'm going to do is, hold on, sorry. All right. Okay, great. So, okay, so I want to talk about a strategy called accept reject, which is a kind of Monte Carlo type strategy for picking random. Oh yeah, and so let me pull up the GitHub issue. Thank you. So, sorry, I got to point this fan a little bit more at me. Look, I like how oh look, if you Google rainbow topics, this comes up. Issues, yeah, random pool selection. Okay, so I'm gonna make this bigger. Yes, I can do this and zoom in on it. Okay. And then I have this, I have this. Sorry, I'm just figuring out, and then here. Okay, so I'm about to do another little section about genetic algorithms, and the topic here is how selection works. The strategy that I'm using, which is building a very large array and putting copies of the elements of the population in multiple times to make them more likely to be picked, versus another strategy called, well, I'm going to call it like accept reject distribution, which is, I think, is like a known thing, right? If I search for accept reject, yeah, I'm going to get rejection sampling. Okay. Also called exception rejection method. Okay, so let's talk about that. Ribra La asks, what program are you using to zoom in? And actually, this is just Mac OS operating system. Control, scroll, zooms in and out of the screen. It's part of the accessibility features of the Mac, of the Apple operating system. Okay. Hello, welcome to another genetic algorithms video tutorial. In this video tutorial, I want to talk about Take two. Hello and welcome to another genetic algorithms video. In this video, I want to talk about something called pool selection based on fitness. And actually this video is inspired by a comment that came in on GitHub from Sinclair ZX81, who writes, "Thanks for the video regarding genetic algorithms. In this video, you suggest an algorithm for pool selection based on fitness." Now, if you remember, what was my algorithm? My algorithm was, I have a bunch of elements in a population like A, B, and C. They each get a fitness score, like a fitness score of 8, a fitness score of 2, and a fitness score of 1. And what I do is I create a pool, a mating pool, not a swimming pool, or it's not any of these things, it's just some computer thing, which is an array. But essentially, I create that pool, and I put A in 8 times. A. I put B in twice, and I put C in once. So the amount of times they're in the pool is relative to their fitness function. And then if I go and say magically, pick me a random element from that pool, I am 4 times as more likely to pick A over B, I'm 8 times as more likely to pick A over C, et cetera, et cetera. So you can see how their fitness, in this case, maps to probability. But this solution is not the greatest solution on Earth, or in the universe, or whatever. And the reason for this, as Sinclair writes, is the method you described involves populating a large array of elements. And this can actually, you might have noticed while I was doing the Smart Rockets coding challenge, like there was a lot of stuttering at the end of the generation. So this can really be a problem. Suddenly I made this array that has like 100,000 or 1,000,000 elements in it, and things can run really, really slow. So Sinclair suggests a different approach for selection, a bit more generalized, and supports arbitrary fitness values and should be fairly quick. So I encourage you to look at Sinclair's code. I'll link to this GitHub issue thread. But a lot of this code uses sort of advanced JavaScript array functionality stuff, which is kind of beyond the scope of what I'm doing. So I'm going to try to implement this strategy that Sinclair outlines in a sort of simpler way, perhaps less efficient, but I'm going to try to do it in this video. Now, what this strategy is also referred to as, often referred to as rejection sampling or accept-reject algorithm. And this is a kind of Monte Carlo method. I always just, if anytime I could say Monte Carlo, I'd like to say Monte Carlo. And if I could just leave and go have some, anyway, I don't want to talk about gambling in Monte Carlo. There's no reason that. Let me come back over to the whiteboard. And so let's talk about how this algorithm is different. What if I could pick, so in this case, I'm picking a single random number, an index into this array. What if we forget about this giant array thing? And what if I were to just pick A, B, or C? I would be picking, if this were an array, 0, 1, or 2, right? I would be picking a random value, 0, 1, or sorry, between 0 and 3. And I would say floor. So what that's going to give me is this function is going to give me 0, 1, or 2. So if I do that, if this is all I do, then, and this should be a 1 up here, if this is all I do, then I have a 1/3 chance of picking A, a 1/3 chance of picking B, and a 1/3 chance of picking C. This will not do because I want to have a higher probability of picking A, a medium probability of picking B, and a lower probability of picking C, scaled according to their fitness. So let's think about what I mean by accept reject. So I'm still going to do, this is going to be a 2-step process. Step 1 is going to be this, pick A, B, or C. Now though, step 2, with an equal probability for each, accept or reject. That's the question I need to ask. I picked 0, 1, or 2, but am I going to accept that as my pick, or am I going to reject it and try again? And here's a way I could do that. What if I also picked a random number between 0 and 10? And if that random number happened to be less than the fitness score, then I'm going to say accept. If it is not less than the fitness score, I'm going to say reject. Right? And you can think about how this might work. Pretty often, if I pick a random number between 0 and 10, that's pretty often going to be less than 8. But very rarely going to be less than, rarely going to be less than 1. Or only 10% of the time it's going to be less than 1. But 80% of the time it's going to be less than 8. So you can see how this idea, and if I accept, then I keep it and I use that parent. If I reject it, then I go back and pick again. So I might have to do it multiple times per pick. But in the end, I'm going to have a way of mapping mapping the fitness values according to, mapping the probability of picking an element according to its fitness value. So this is the theory behind it, and let's go try to implement that in code. Oh, I'm over here now. Wait, was I in the right, hold on, pause. I was over here this whole time, right? The chat is like, use a voice recorder. Oh, use a voice. Was I in the right? I was in the right place, right? Yeah, okay. Sorry. Okay, so I'm going to, sorry, Mathieu, I've just made an edit point for you. But I'm going to just pick this back up, walking over here, like this, but not right now. In love with that sound effect a little bit too much. Okay. Okay, so coming back over here, I want to show you something. I actually have a processing example that I will link to the source code for this. And before I get to the genetic algorithm, I'm just going to run this example. And what this example is doing right now is it's picking random numbers between 0 and the width of this window, and it's graphing the distribution of how often they've been picked. And look at that. I'm getting kind of an even distribution from and it's kind of normalizing them to the height of the window. It's doing all this stuff. So you can see over time, a good random number generator should pick an even distribution of numbers across the spectrum of what you're picking. But I'm going to now change something really quickly in the code, and I will and run it again. Now look at this distribution. So this is now a program that's picking random numbers between 0 and the width of the window, but it's much more likely to pick higher numbers than it is to pick lower numbers. And you can see this graph is actually just a linear graph of like y equals x. And how is that working? Well, I have this function called accept reject. And notice what it does is it picks two random numbers. Why am I casting it? I must have written this at one point in like Eclipse or something, because it's totally unnecessary I don't know why I have that there, that extra, it still works. You can see that it picks two random numbers. And what it does is it says, and this really, I'm going to change this variable name, like probability. The probability whether or not we should accept random number 1 is equal to random number 1. So the higher random number 1 is, the higher its probability. And then I just check, was R2 less than the probability? If it was, return that value, otherwise go back and pick again. And I have this like goofy little thing here, this hack, where I'm like, if for some reason I tried to pick a random number 10,000 times and I didn't get anything, then something is going wrong, and let's at least get out of here and not like be in an infinite loop. But you can see how this code kind of works. So what I want to do now is try to take this same idea and bring it into the genetic algorithms. But rather than have the probability be based on the random number itself, right? I want the probability to be based on the fitness of that particular element. Okay, so I'm going to go back. I'm going to leave processing, and I'm going to go back to JavaScript, and I'm going to look for this natural selection function. So let me just make sure. I'm going to hit save. This is the example that I'm running. It's this to be or not to be. That is the question example, which is trying to evolve to be or not to be. And I'm going to go back to here, where I'm creating this mating pool. So I am now going to get rid of this mating pool. Zonks. Goodbye, mating pool. I am still going to look for the maximum fitness, and I think I will still, sorry, I'm, pause. I'm thinking here. So this particular example normalizes all the fitness values between 0 and 1. And so I think I can still do that. I don't really need to. You know what? I'm going to not do it. Because I could just use the maximum fitness as the top of the range of the random number the second random number that I pick. Okay. Coming back into the video. Okay, so I'm going to keep this maximum fitness. You're going to see that I'm going to use it in a second. But I don't need this whole thing where I build this extra mating pool. And in fact, this whole function is kind of irrelevant except for this maximum fitness value. So I'm actually just going to take this out and do this maximum fitness thing in the generate function. So right here, this is the issue. I need to replace this part of the code. This is the part of the code where I pick parent A and parent B as an index into that particular mating pool. But I don't want to do that anymore. Instead, what I want to say is, I'm going to just have another function. I'm going to say accept, reject, something in the population. I need to pick a random element in the population, and I also need to know, I need to pass in that maximum fitness will be a value. I need to write a new function called accept reject. And you know what? It can just be in this object. So I think it'll be nice to encapsulate this in another function rather than write the code here, especially since I have to do it twice. So I'm going to write this down here now as, this dot accept, and I forgot. Oh my goodness, never mind. I was trying to use my soundboard. I'm going to write a function called accept reject. Okay? And what I want to do is, the first thing I want to do is pick a random index. So I need to say random number between 0 and this dot population dot length. And the 0 is kind of an optional argument that I don't need. So I need a random number between 0 and the length of the population, and I want to floor that. Then what I need to do is pick another random number. I'm just going to call that R, which is a random value between 0 and maximum fitness. So I want some value that goes between 0 and the maximum fitness. If R is less than, so now, the member of the population, the partner, the parent, is this dot population index. So this is the actual partner that I picked. So I'm picking a random element from the population. This is kind of, and then I want to get like that, the index into the array, and then I want the actual object itself. Because what I want to test is if that partner's fitness is less than R. Let's think about this. No. If R is less than that partner's fitness. Let's think about this, right? If the fitness values go between 0 and 100, I'm picking a random number now between 0 and 100. If the partner, if this particular element has a fitness value of 100, the random number is always going to qualify. I'm always going to accept it. If it has 50, it'll be 50% of the time. If it's 25, the fitness is 25, it'll be 20% of the time. And I can say return that partner. Otherwise, what? Do it again. So I want to say while, I'm just going to do this, while true, over and over and over again. The return will get me out of this function. So this accept reject strategy is going to always pick a random population, member of the population, pick a random number, and if it qualifies, if it should be accepted, return it. I'm forgetting some this dots, people are telling me in the chat. Line 51 and 52. Yep, thank you. So now this should be this dot accept, this dot reject, this dot accept reject. Okay, so the other thing I want to do is I'm just going to say be safe. Be safe equals 0. Be safe plus plus. And if be safe is ever greater than 10,000, return null. I don't know what this is really doing, but I just want to get out of that infinite loop. I feel like something's wrong if this takes 10,000 times to find a correct value. So let's look at this and let's just see. I don't know, how did I do? Let's run this. Okay, so clearly I'm getting an error. The error is population.natural selection is not a function. Right, I eliminated an entire function from this particular scenario, sketch.js line 40. So I'm going to go to line 40, and I'm going to delete this function. Doesn't exist anymore. Max fitness is not defined in line 65. Oh, right. So here's the thing. What I'm going to do is I'm going to just make this an argument, max fitness. And I'm going to give that max val. I'm going to just pass that in because that'll make things easier. Crossover of null. Oh, so perhaps this isn't working. So I think it's getting null, right? So let's look at console.log partner A. So let's run this. Oh, it worked, but it got null. Did it really just, okay, so the fitness values are really, 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 really small. So that's a little bit, could that really be the issue? But the maximum fitness values are, so let's think about this. Let's make this 100,000. Why am I getting null at some point? Just, okay, it's working, but it's really, 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 really slow because it's got to run it so many times. So let's think about this. Let's look at max val. And let's not look at, let's look at the maximum fitness. Let's look at what that is. I'm debugging this live, and I've also like totally crashed my window here. Where was I? Sorry, I should probably edit this out, but I'm not going to. I can't find chapter 9 genetic algorithms. This one, okay. So great. So what I'm looking for at 52, I don't want this to be printed out. I want to see the max fitness. Max fitness is this value. And let's make sure. All right. Actually, so this video should probably have been paused a little while ago. So I've got to debug this, and this is too much debugging. So let me figure this out. Let me think about this. So why is this taking so long? Let's look at, let's take this code. Let's look at, let's look at a bunch of values. So what I'm getting here is that this value is the partners. Oh, there's an issue where at the beginning, almost all of them have such a low. So I should normalize the fitness values because, first of all, so many of them have a fitness value of 0. Doesn't really matter though. The max fit, the fact that I'm let me see. Let me put something in here to see how often this happens. So you can see like it's did it so because so many of them have a fitness of 0. Yeah, Kuba, I don't know how to do that. I guess the best way, Kuba's asking in the chat, could you add a description live so new viewers would know what you are doing? I don't have a good way of doing that, but I guess if you ask in the chat, then other people will fill you in. So what I want to do is figure out, so that I've got a problem where most of the fitness values are 0 when it starts. So what's a good way around that? Well, one way around that would be in the fitness function itself. Oh, I forgot that I have this crazy fitness to the power of 4 thing. Let me take that out. But I still have, so now the fitness values are less sort of like crazy looking. And I'm getting acceptance more often. But there's still a lot that have a value of 0. So what if I did this? What if I gave everything at least a fitness of 0.01? then maybe where am I printing this out? Population. Partner fitness. So nothing should have a fitness of 0 now. Yes, there we go. Okay, why are things still have a fitness of 0? I'm trying to debug this. Yeah, I know. Okay, let me look through this code here. Where do I think I probably messed something else up. Generate calc fitness. Oh. Let me just look at what the fitness values are. Okay, that's right. That's what I should be getting. I have a idea that there's something going on in the main program in the order that I'm doing stuff. I'm calculating fitness after. There you go. Population.evaluate. Okay, so I should calculate the fitness. Then I should say generate. So why? Oh, okay, I see, sorry. Should see all the fitness values. Okay. And now accept reject max fitness. Okay. Population line 52. So I'm still getting null sometimes. Let's look at this for a second. Why am I getting zeros? No, I know, but why am I getting zeros here? How could there be members of the population with a fitness of 0 when here I just confirmed that nobody has a fitness of a 0? Okay, hold on. Let's. Yeah, so there's a lot. So stop. Okay, crash the browser. I crashed this browser window. Oh, population line 67. Oh, break. Okay, hold on, genes. Fitness is 0. Oh, I think I know what's going on. Hold on. Alvaro. Alvaro, I just made it possible that you can post links. Hold on. Something is happening here. I think I know what's going on. Look at this. Can't read car out of undefined. Genes. Something crazy is going on. Oh my goodness. Look at what I'm doing. I can't do this. This is crazy. Has this been in my code all this time? There's a horrible bug in this code. I have to get the soundboard back up. Hold on. Is it just completely gone? I have to play my... Do you guys see what it is? There's a ridiculous bug here. I can't believe that I've been doing this all along, that this is in every example that I've written. It can't be. Because look at this. I'm overriding the population. I must have just done this in the port by accident. Because this needs to say new pop, right? I need to make a new population. And then this is what was causing the problem. Right? I was overriding the current population with the things I was evolving, and then those were going to be picked as parents, which is like radically wrong. Yeah, so I've got to get back into this video in a second, but I just want to check something. I'm going to open... I'm just going to look at recent downloads of my processing examples. And this has been around for a really long time. And I can't believe that nobody would have noticed this. Yeah, I'm doing it in this too. This is crazy. What is wrong with me? Oh, it doesn't. It's not a problem when I have the mating pool, because I'm not going and picking from the population rate. So it hasn't been a bug all along. There was not a bug in my code all along. Yay! This is the not a bug in my code all along dance. But there just was a new bug now. Okay, great. I don't know if you guys are with me here on this, but I am going to, let me just see if this runs now. There we go. The average fitness thing is broken, but this seems to be working. It's taking a lot longer to evolve. But you know what? I think I have things out of order again. Now I know why. Okay, hold on. Okay, yeah. We just want to make sure this actually works. I can go back and make the fitness function have to the squared, and I'm going to get null again. DNA.js 41. Yeah, so I want everything to have a little bit of a probability. You can see it got there, but it didn't stop. So hold on, I just, why did it not stop? I just want to make sure I have everything working before I go back into the video, then I'll back out of this and implement it correctly. Coffee is finished. Why is my is finished test broken? Wait. World record, evaluate. Yes, I am doing more genetic algorithms. I got sidetracked by a bug, and now I have another bug, which is really not that important. But I kind of would like it to just work the way... Oh. Perfect score. What is the perfect score? Oh, 1. Oh, because... okay, sorry. Okay, perfect score. We are not to be... Come on, you can do it. There we go. Okay, great. Okay, so hold on. I figured out what all the issues are. And I'm going to come back into this video, but I need to get to the right place, which is not. Okay. Okay, this is what I was doing. And so I need to do this. Hold on, I'm taking out some of the fixes that I made so that it's broken again. And then I will fix it. And then I also want to go into here and take this out. Okay. I'm going to go back to this video here. Sorry, so, okay, actually, before I go back in, there's a lot of people in the chat who just got here. I'm working on a new algorithm for pool selection for picking parents in a genetic algorithm. It's called accept. It's called rejection sampling. It was suggested in a GitHub issue thread, and I was building up and talked through the algorithm and was writing the example, and I ran into a bug, and then I just spent a while figuring out the bug, and now I'm coming back to the rest of this particular tutorial video. So I'm back after a little bit of debugging. I had some sort of significant issues. You can see right now what's happening is I'm not kind of getting any evolution. There's a couple reasons why this is happening. Number one is that the fitness function that I'm using, at the beginning, when I pick a lot of random phrases, a lot of them don't have any correct characters, and I'm getting a fitness function of 0. And in this new algorithm that we've designed, if the fitness value is 0, this thing has no chance ever of being picked, because I can never pick a random number between 0 and something that's less than 0. So as a little bit, this isn't the best solution, but as a little bit of a hack, I'm just going to, in the fitness function, add 0.01. So I can, at a minimum, the fitness function is 0.0. The fitness value is 0.01. So everything has at least like a 1% chance of being picked according to this rejection sampling model that I'm now using. But there's another significant problem, and I could run this. I could run this again now. And it's sort of doing some stuff now. It's going to break here and there or do weird things. And it's not really evolving very well. There's also a major issue. If you notice in the code, if I go back to this code, this is what I'm doing. And the comment says it all. Refill the population with children from the mating pool. So what I was doing before is I had a separate array that I was pulling from to create child objects to put in the population. But I'm no longer doing that. I'm now actually picking from the population to put things back into the population. But I can't be putting the next generation into the population while I'm continuing to pick the current population. So what I need is a whole separate array. I'm going to call this new population, and it's just an empty array. And instead of filling the existing population, I want to fill that new population. And then at the end, I can happily say this.population equals new population. So that is a fix that I also need here. And now I should be able to run it, and we should see that we're back to our old tricks again. We've got to be or not to be evolving. Now, it actually, I think there's going to be an issue. You can see it got to be or not to be, but it's still going. There's a reason why it's still going, because I have a bit of code that says, somewhere I believe in the in evaluate here, yes, it says if the best fitness is equal to the perfect score, then you finish the simulation. The problem is the perfect score is 1, but remember I added 0.01 to it. So I'm just going to change this to if it's greater than or equal to. The perfect score being 1, 100% of the characters correct. But I'm just going to check if it's greater than that now because I added that 0.01 thing. So now we should run this again, and we should see this is doing exactly what we did before. So there's really, my assumption here is there's not a significant difference between the behavior of this version of the genetic algorithm and the one that I did with the building the large array mating pool. But using this accept reject strategy, this rejection sampling strategy, I've done away with this giant array thing, which I think in a lot of scenarios can be a useful solution to use as well. So as an exercise, you might go and find the Smart Rockets example that I built in a previous video in the coding challenge and see if you can take that and apply this accept reject algorithm. And in that one in particular, I know I was building this really big array, which was making it run kind of slow, and see if it runs faster with this algorithm. Okay? Thanks for watching this video. Okay. All right, so I have now done. Okay, I'm going to go to. I'm going to go to the Rainbow Topics issues. I'm going to go to genetic. Actually, I can just sort it by this, and I'm going to go under genetic algorithms, and I'm going to look at this, what we've been doing. Okay, so what have I done? I have now done something on better fitness functions, and I have also done something on. What have I done? What did I just do? A rejection sampling instead of giant array as per what issue is that? As per 119. Okay. So I only have 2 more things left in this series about genetic algorithms, and I think I want to try to do that today. What is it? What time is it? 12:30. So I think that I might really wrap up all of these topics in genetic algorithms. So I want to talk about interactive selection and also this idea of an ecosystem simulation. Okay. So I need to get myself organized here. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot's on this dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot's on this dot, this dot. This dot, never forget this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot's on this dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. Okay. Okay, I think I'm just about ready here. Just doing some formatting here. Let's grab this paper. Interactive selection. Whoa! That didn't work. That link doesn't work. Here we go. I think this is. I think this is what I'm looking for. Yeah. Okay, so that's a new link for that. SIGGRAPH 1991. Okay. So I'm going to. Here we go. Okay. Close this. Got this open. Fresh. Okay, so I am about to talk now about something called interactive. talk about something called interactive selection. Interactive selection is this idea of having a fitness function that is not calculated by some mathematical function according to the performance of some objects or the result of some type of math formula, but rather is a fitness function that's assigned or picked by a viewer or a listener or a user through a rating system or some type of other kind of behavior. And so I think there's a lot of interesting possibilities with this. So I would like to do a video tutorial on that. And I think this is kind of a seminal reference to this idea. And there are a lot of things that come up with I'm trying to think if there's a more recent example of work in this direction. But I can't think of one. So here we go. Get warmed up here. Okay. Oh yeah, look at this. Sorry. I just want to think of something here. Is there... Yeah. Okay. Do it yourself, Darwin. Okay. Okay, here we go. Hello, welcome to another genetic algorithms video. Boy, I seem to be making a lot of these genetic algorithms videos recently. In this video, I'm going to explore something called interactive selection. The ideas, a lot of ideas behind interactive selection pioneered by Carl Sims. Here is a reference to an artwork, a project created in 1997. It's a museum exhibit. You can look kind of here at this image. And what you see in this image are a lot of screens. And these screens are displaying images. And then you see along the floor here all of these sensors. So a viewer at this museum exhibit would come and stand in front of an image. And when the viewer is standing in front of the image and looking at the image, they're standing on the sensor. And some type of counter or some type of algorithmic system is keeping track of how long the viewer is standing on top of that sensor. Why is all of this happening? Okay, so I've said before that when you're designing a genetic algorithm, there are kind of two key things that are up to you to develop yourself. One is this idea of genotype versus phenotype, and I'm going to get to that in a second. But the other is the fitness function. So what is the fitness function? Sorry, pause. This green pen is no good. I'm going to, apologies again to Mathieu, who will have to edit that part out. I'm going to go back to writing on the board there. And I'm going to use a black or purple. Where's my black marker? I don't know what happened to the black one. This one, let's see if this one will do. This should do. Okay. Here I go again. When I have talked about... Take 3. Totally forgot what I was talking about. Oh, yeah. When I've talked about using a genetic algorithm in a project, I've said there are two main things that are really up to you to design, that your sort of creative input into what's going to happen in your project. One is this idea of a genotype versus phenotype, which is also a really sort of key factor in the Carl Sims project that I'm showing to you and the thing that I'm going to demonstrate and make for you as well. But really what I'm talking about right now is this fitness function. And the reason why I've come over here on the whiteboard to kind of write that down is usually the next thought from here is, what is the math formula for the fitness? Well, it's, inverse distance squared divided by the amount of time it took to do this and the blah, 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 blah. You're coming up with some kind of number of characters correct, blah, 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 some type of actual mathematical function. Well, in this case, there is nothing other than the amount of time a viewer spent looking at a particular image. So in this case, it's the behavior of the visitor to the exhibit that is driving the fitness function. And you could think of this in a lot of other ways. You could have a rating system. You know, the fitness of a particular piece of music is the amount of star ratings it got on some, you know, music sharing web service type of thing. So user input into the fitness, user-driven design, right? You could be saying, I want to design a particular pattern for a dress, but instead of hand making that design, I'm going to just have a program algorithmically generate 100 designs. I'm going to look at them, pick the ones I like, and generate 100 new designs. So you could evolve where you are essentially the designer assigning fitness to the things in the evolutionary system, and that's what's happening here in this particular exhibit. So how would you do that? I mean, this is really all I have to say. This video is really more about this idea, and actually it becomes, you know, there's so many possibilities. Do I write a web application, or do I create something with computer vision? And perhaps I can explore, if you have some suggestions, some particular scenarios. But I have for you just to look at some code and see an example happening. I have perhaps what might be the lamest version of interactive selection ever. And I'm going to show you this example and talk you through the code a little bit. So this is the example right here. And what it has that you can see if I zoom in here is a bunch of different designs for faces. And as you can see, as I hover my mouse over them, I am incrementing a number. So I'm saying here, like this, I really, really like this particular face design. So I have these designs. I have about, I think there's 10 of them here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I've given them all a rating. And then I have a button here that I can press, Evolve Next Generation. And I click that button. And you can see I now have a new generation of designs from the ones that got a high rating. And I can say, you know what, I love purple. Let's give this one a high rating. But the size of this one's pretty good. And let's hit Evolve. And you can see I've got a lot of purple ones now. So again, and I can keep hitting Evolve. And you're going to see there's some mutation at play and things happening. I'm not suggesting to you that there's anything particularly revolutionary about this, but it is showing you the basic mechanics of this system. So let's think about how this works. Number one is I'm using some form of interaction, like a rollover, to increment the fitness value for a particular face. And then I also have this idea of a design. So there's also this question here of oh, there was nothing written there. There's also this question here of genotype versus phenotype. So in Carl Sims's example, if you read the paper that I've linked in this video's description, there's an elaborate discussion of how the images in the exhibition are created out of these kind of like mathematical formulas, sequences written in the programming language Lisp and all sorts of craziness like that. But what I'm actually doing in my particular example, which is quite a technique that you can apply, is I actually have a DNA. The DNA is actually just a sequence of floating point numbers. And each floating point number is between 0 and 1. So that is the signature for the design. And if I go, you can see we have this idea of genotype and phenotype, if I look at the code very briefly. In DNA.js, you can see this is the genotype right here. This is the data. An array of genes, everything with a random number between 0 and 1. And then the expression of that data is in the face object. And the face object, right here, you can see that expression happening here. So this face object has a lot of parts of its design. It has a radius, an eye X and Y position, the size of the eyes, an eye color, the mouth position, the mouth width, the mouth height. And all of those things are taking these numbers between 0 and 1 and mapping them to some other range, like a color between 0 and 255, or a position between 25 and 60, that type of thing. So this is one way of taking this idea of data and then mapping it to a bunch of variables, which then draw this kind of ridiculous design of a face with a couple rectangles. So I think that you, as a person watching this video, probably could come up with a much more creative or beautiful or interesting type of design. Perhaps you can think of it as like a vector-based shape of paths, or you could think of other ways of encoding your design. Maybe it's a piece of music, so it's not actually even a visual design, it's a sequence of notes and rhythms. But whatever that is, then you just need a rating system. And in this case, I had to have this rollover function that whenever the user is rolling over that particular object, the fitness is going up by some small amount. Pretty arbitrary, but you could have a drop-down menu to assign ratings. But one of the things that I think is kind of key to realize about this kind of system, so if I go back to show you just really, really briefly, if I go back to this Shakespeare example, right? The Shakespeare example, look at this. In the time I talked there, I evolved 175 generations, each population having 200 elements. let me run this example for you again. And there's 10 elements in the population, and I'm clicking around. Oh, and I've got to actually rate some, and I got 8 generations with 10 elements. So the scale here is a bit of a problem. While with this kind of numeric fitness function of mathematical calculation, I could just be churning out generation after generation after generation after generation over and over again. But here I've got to look at it, I've got to evaluate it, I've got to think about it, I've got to roll over it, then I've got to click the button. So scale is an issue, but one thing you might think about is the web, the network, a distributed network of viewers. Could you create some type of system? Maybe you could have a website, by the way, that has a different design. This is kind of an awful idea, but you have a website where you want somebody to buy something, or think of something besides buy. You just want someone to download a nice flower image because that's going to make the world a better place. What if you showed a different design each time somebody came to the website, and the sort of rating of that design was how likely that, whether or not that person got to sort of some end result of using the website? You can think of it this kind of ties into this idea of reinforcement learning. But you could evolve a particular design through users' kind of unconscious behavior of just kind of using a particular website, whether it's intuitive or not, or playing a game. There's lots of possibilities besides just rating. But the point is, if you have something up on the web, you can have a lot of people rating and evolving all at the same time with like a centralized database. Anyway, I'm rambling on and on and on in this video. You can find this code linked to in the description of the video. I hope that you maybe try to make your own evolutionary design system with interactive selection and share it with me. And so we can see what kind of new and creative ideas. And maybe if you share some with me, I'll come back and make a video where I show some of them, and so that you guys can see what other people have been making. Okay, see you soon in another video soon. I got one more genetic algorithm video, at least coming in the pipeline here, that'll be after this one in the playlist. Okay, goodbye. Okay, so it's interesting because I had somebody, I can't remember who, say in the chat or in the YouTube comments that they don't particularly like the videos where I just show an example and talk about it. The videos are much more fun and interesting and engaging where I actually just sort of build the example. So I could have actually done a coding challenge where I make this whole project, but I'm trying different things. And so hopefully you got something out of this. Okay. I have one last topic about genetic algorithms that I want to put into a short, 5 or 10 minute video to describe it. So I'm going to do that now as well. So let me go to this particular example. And I just want to run it a little bit, get the code up. Where am I here? What other music do I have for you guys today? I don't really have a wide selection.
So this is random, this is noise.
This one uses Perl and noise. This will be a good song.
In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I pick 9 a lot, apparently. But with Perl and noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6.
Thanks,
7,
Alvaro,
5,
for the nice
7,
feedback
5,
in the chat.
6,
Okay.
7, 8, 9, 8, 7, 6. Well, this is like Perl and noise performance art. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1.
Okay. All right. So I think I am ready. I'm just watching this example to see if it's kind of behaving the way I expect it to behave. I'm going to let it run for a little while. I haven't really actually tried messing with the JavaScript version of this example in a while, and I'm just sort of curious to see what kind of results I get. All right. So this I'm gonna come over here and erase the whiteboard one more time. I'm going to come back over here. I'm just looking at the time. This has been about 2 hours, which is pretty good length. This is what I think about 2 hours in is usually when I start to lose it and my brain starts to melt and I don't make any sense anymore. So this is mostly behaving like how I expected it to behave. Not 100% exactly, but I'm going to refresh it and let it run one more time. But that's fine. I'm not too worried about this. I am going to close these other windows. Oh, I didn't reference that, but that's okay. And, oops, recently closed this one. Okay. Now, I actually want to go to the Smart Rockets example. Hold on a sec. I got to go to CodePen. So I made this example in a coding challenge. So how do I open my pens? No, these are Explore pens. Do I go to here? Your profile. So this was the one I made yesterday. I want all this JavaScript code, and I want to save this somewhere. So let me do this. CodePen, Smart Rockets. Don't worry, this will all make sense in a moment. Let me open this up. Oh, let me go back to CodePen, get all this JavaScript, save it, and I'm going to take the population function and put that in population.js. And I'm going to take the DNA function and put that into DNA.js. And I'm going to take the rocket function. So this is, by the way, what I'm doing. This is an example that I built from scratch in yesterday's live stream. And oops. And so I should now, obstacle is not something that I'm using, but that's fine. I should now, if I go here, CodePen Smart Rockets, great. So this is the example that I made yesterday. And let me let this run for a little bit. Oh, it's got an error. Cannot read property crossover of undefined. Shoot, I want to fix this. Where's my debugging song? I'm debugging this code. Okay, population.js line 39. Let's see here. There's some sort of error that maybe I didn't build the mating pool correctly. And I gotta wait till it gets to 400 to find out. No, that was good. Oh, I know what the problem is. Haha. Old version of P5.js. I used a feature that's new to P5.js. And I need to put the new P5.js library in, which I definitely used in the Phyllotaxis example. So now I can go to here and replace all the libraries, and this should fix it. Okay. So let me let this run for a minute. These rockets aren't very good at evolving past the... Where do they still have a console.log? Oops. Hold on. Hold on, everybody. Maximum force. Where did I put the maximum force? Is that in the... Oh, yeah. Didn't I limit the speed somewhere? Okay. Okay, that's good. I'm gonna let this run. It'll get there soon enough.
So this is
Okay, great. Camera. Okay. Sorry about that, everybody. Okay, I'm back. I am going to now talk about this last piece of genetic algorithms, which I'm calling ecosystem simulation. I'm going to close this. And what I want to show you here is here. There's a sort of key. There it is. Okay, so this is a sort of key piece of code that I will refer to. Okay, here we go. I'm going to do a couple jumping jacks. Warm up. Stretch the body out. Okay, I'm ready. Hello and welcome to one more video about genetic algorithms. This probably won't be my last video ever about genetic algorithms because I do have some more in my head that I'm planning to do at some point. But this does kind of wrap up the range of ideas that I've been talking about in this series of videos that you may or may not have been watching so far. But I want to talk about sort of a fundamental flaw in the examples that I've been showing to you. So this is the Smart Rockets example that I built as a coding challenge, kind of playing out. And what these rockets are doing is they're evolving a kind of path from the bottom of the screen to this target. And they have this DNA built into them, which is a lot of vectors, forces to kind of push them around the screen. And over time, they're trying to get around this obstacle and make their way. And if you run this for a while, eventually you'll get there. But let's think about how this system works as compared to the real world that you and I live in. So let's say these aren't smart rockets, but they are monkeys, and these monkeys are evolving. The scenario that we have here is kind of like, okay, let's have 100 monkeys all born at once. Then let those 100 monkeys live for exactly 200 frames of animation. Then all 100 of those monkeys immediately have 100 children and die. And then the next 100 monkeys live for 200 frames, then they all at exactly the same time all die but have 100 children first. So this idea of this sort of cycle of generations, of a generation all growing up exactly together, then the next generation growing up exactly together, it doesn't really mirror the way that a fluid system, a continuous system, like our actual natural biological world works. So something that you might think about for a creative project, if you're doing a fish tank simulation or some type of other type of simulation of kind of creative imaginary creatures living in an ecosystem, is how might you create an evolutionary system that is continuous. And I have an example of that for you. I'm not going to build it from scratch here. And this is a system of bloops. And this has actually been running for a while. And each bloop, I'm calling them bloops, being this circle. I'm saying bloop as if you know what a bloop is. I don't even know what a bloop is. But let's talk about this. So here's how this system works. There's this idea of a bloop, and it is represented on the screen as a circle. And each bloop has DNA. And the DNA is an array. But it's actually, I'm making you a very, very simplistic version of something that you could adapt and expand on. And that DNA has a single number between 0 and 1 in it. So a single floating point number. So here might be a bloop that has a number 0.1. There might be a bloop that has a number 0.5, there might be a bloop that has a number 0.9. This one might look like this one might look like this, and this one might look like this. So the DNA, its single property, is mapped to its size. Smaller, medium, big, from 0 to 1. But it's not just mapped to its size, it's also mapped to its speed. So the smaller it is, the faster it can move. The larger it is, the slower it moves. And I'm going to come back over to the program. And you can see this has been evolving for a time, and you can see the kind of like magic here is that what the system evolves to is like medium-sized objects. But I'm going to refresh this. You can see at the beginning, there's a lot of little things squirting or moving all around the screen really fast, and there's big ones kind of moving around the screen rather slowly. You can see they're fading out. So the difference here is that these bloops just live out a life. They have a timer built into them. If I look at the bloop object, right, there's a bloop object, and it has as part of its a variable a health parameter. That health parameter just counts down. There happens to be food. There happens to be food around the screen. So here's the thing. Something that's small is able to move around the screen very, very quickly. But because it's small, it's less likely to bump into the food. Something that's big moves around kind of slowly, so it's less likely to find the food, but if the food is anywhere near, it's going to likely bump into it. Medium, it kind of moves medium speed with a medium size, and so this system tends to optimize towards medium objects, objects that can move with some speed and are big enough to by accident find the objects. And the motion here is not that interesting, it's just kind of random wandering, Perlin noisy type motion. But what you'll see, the sort of key factor here is that when an object dies, it fades away and it's gone. How does the genetic information get passed from one generation to another? I don't just put in 100, have them all live, have a score at the end, and they just, each one, as it's living out its life, we can see there is a function in the bloop object called this.reproduce. And what, I'm going to just delete some of the comments here so we can look at this more easily. What this reproduce does is it just, every single frame of animation, it picks a random number. And if that random number happens to be less than 0.0005, then a child is born. So this mirrors more closely, of course it's not exactly like our biological world, but something that lives a longer period of time has more chances to perhaps find a partner to mate with to pass genetic information down to the next generation. Now in this case, these bloop objects are just cloning a version of themselves. There's no two coming together to cross over genetic information. It just makes a copy with a mutation. But so the longer it lives, the more likely it is to make a copy of itself. So we can see here, as if I run it again, you can see these little tiny ones speeding around the screen. They're just going to fade out without having a lot of chances to reproduce. The big ones are going to kind of fade out without having a lot of chances to reproduce, but the medium-sized ones are going to last for quite a while. Some other strange artifacts happen. Actually, when one of these objects dies, it leaves a piece of food right there. So sometimes you can have a cluster of the big objects all sort of dying, leaving food, and then like kind of eating the leftovers, so that some sort of interesting things can kind of happen even in this like really, really basic simulation. But I think the things for you to think about are what might be a system like this where the rules that govern the motion of these objects are more interesting. You could go back and look at some of my video tutorials about steering behaviors. What might be other rules that govern the way things find food or move around or escape predators in an ecosystem simulation? What might be a system where instead of just every frame of animation, there's a small chance an object might make a copy of itself? What about every time two objects come within a certain distance, there's a chance that they might perform crossover mutation to make a new sort of child object? So there's a lot of possible ways. You know, what can you have? Can you make an object with more than just a single property? What about its design? Could you see different colors being passed down from generation to generation, a certain color taking over? So there's all sorts of, I think, possibilities in working out a system like this. So this system, it has crossover and mutation, it has genotype and phenotype. The thing that it doesn't really have is a fitness function. There is no fitness assigned to any of these objects. Fitness just is something, it's not survival of the fittest here, it's survival of the survivors. The things that survive longer have a more likely chance of passing their genetic information around to the next, down to the next generation. Okay, so I'm sure you have questions about this, ideas about this. Please write them in the comments. I'd love to see if you make something from this or create an interesting idea out of this. And I will perhaps do a follow-up video if there are some new ideas that come out of this particular one, of some new techniques and things that I can demonstrate for you. Okay, thanks for watching. Oh, and the code. The code is, you'll find it in the description of this video too. Okay, goodbye. Okay, great. So hopefully that was interesting for you guys. I think I'm kind of losing steam here a little bit. I feel quite satisfied in that if I go to this particular, if I go here to genetic algorithms, I can now also edit this and put an X here and an X here. So this is now, one thing I'll point out is, so I've made all of these videos so far. There's how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. But right now, the content for this stuff is only found, stretched out in all of the live streams. So Mathieu, who is helping with editing stuff with me, he's in the chat, I'm giving some feedback and offering comments as well, is busy with some other projects this particular week. So, but there will be, next week is really the Darwin Days, the Shark Week of Coding Rainbow, the Genic Algorithms Week of Coding Rainbow, where hopefully we'll be releasing all of these as standalone videos as well. So you can obviously, those of you who are kind of following along closely and tuning into the live streams can find this sort of stuff and watch these super long streams, but I will have shorter versions of these video chunks that you can mix and match or add to your playlist. And one of the reasons why I'm doing this is, especially for those of you who might be a teacher or teaching a workshop or teaching a class, one of the reasons I'm doing this is so that you could design a syllabus, and if you wanted to, you could pick and choose different modules that I'm doing in coding challenges or short little playlists that you could add to your syllabus. So to keep me posted, how things are organized, how you're able to find things, if you have feedback, a better way to organize things, I'm always willing to listen and that sort of thing. Okay, so when I woke up this morning, and thought to myself, oh, I know what I want to do. The traveling salesperson problem with genetic algorithms. And I know if Oliver were here in the chat, Oliver would somehow manage to talk me into doing it right now. But it's about 2 hours and 15 minutes into this live stream. It is 1 p.m. I don't think I'm at my best, especially in the heat and being in this room, talking and programming for over 2 hours. I'm feeling the rumblings of some hunger here for some lunch. So over the next couple days, I'm going to be working on the second edition of my Nature of Code book. I have a new chapter about neural networks and machine learning. I'm going to be doing some more research and examples in that direction, trying to write a processing library that maybe I could also use in JavaScript for some machine learning algorithms. And so that I'm hoping if I can get some traction on the next couple days, I'll be able to come back next week and maybe even tackle some of those topics in a live stream. I know Alvaro's doing a good job of trying to encourage me, but I'm pretty determined. But so I'm going to put on my goodbye music, which is the same as music that I've been playing all along. But I am here. This song takes about 3 or 4 minutes to play. And if you have some questions that you want to ask in the chat, I'm here open and taking questions. So while I'm waiting for your questions, I will remind you that codingrainbow.com is the website. You could go there for all of your Coding Rainbow needs. You can subscribe on YouTube. I always appreciate that if you hit the subscribe button. I'm using Patreon, which is a crowdfunding website. If you want to become a patron, you will get an invitation to a Slack channel where people ask questions and share work and discuss topics around Coding Rainbow. I also should just briefly mention that there are only 2 days left. This Coding Rainbow t-shirts. cottonbureau.com/product/coding-rainbow. Shipping to outside of the US is possible, but a little bit tricky and expensive. But if you're interested in a t-shirt, check it out. There's a bunch of different colors. But this is a limited run that's going to end on Friday. Okay, so wait, hold on. I'm trying to figure out, there's a way that I pause the music, which I think is, shoot, I know I can use the mouse to do it. No, pause. Okay, question. Alvaro in the chat writes, Daniel, did you ever see my tweet about the processing jam idea? I think I did, yes. So if I'm correct, your idea was to have like a jam session where people get together in person and maybe work on a project or do that kind of thing. I would love to help support and facilitate something like that. I don't know the best way to do that, and so my hope is that maybe some of you who might be interested in that could open a GitHub issue thread. If any of you are patrons, you could discuss this in the Slack channel. You could go in the processing forum and maybe open a thread there and kind of self-organize. Whether this is something that would happen people remotely as part of a Google Hangout or with a live stream going, or could happen in some city in Europe or a city in the United States or some other part of the world where there are a bunch of people. I would love to help facilitate and support something like that. So yes. Let's see, some other questions. Would you be interested in creating an agar.io AI with this project? Definitely. Everyone keeps suggesting this agar. I must be like an old person. I'm turning a new age on Friday. Everyone keeps saying to me this agar.io thing. So this is like a game. I'm going to look into this. This even more than Pokemon, maybe this will get me some subscribers. So yeah, there is, I think, if you don't know already, if you go to the GitHub repository coding rainbow/rainbow topics, the issues is where you can post ideas. And if I search for agar, coding challenge agar.io is number 83, and it has 4 thumbs up right now. So if you want me to do an agar.io coding challenge to kind of, I don't even know, I'm kind of Agario, I don't know if I'm saying it correctly because I'm an old person and I don't know this game. But if you would like me to tackle this, put your thumbs up there and it'll rise to the top. You can see if I go to the issue thread and I go sort by thumbs up, you can see what's kind of at the top right now, these particular topics. Okay, Daniel, Chun writes, Daniel, I'm new to coding. Can you share some typing tips or commands that speed up the general coding process? Great question. You know, I think this comes down to what type of text editor you use and what features it has. I've been using Atom, which I've been enjoying. A lot of people use Sublime as a text editor. When I work with processing, I use the processing editor itself. And a lot of coding environments will have something called autocomplete or autofill or various configurations that you can set up shortcuts for, like, you know, something that I use a lot is if I want to comment out this entire function, I do command / that comments it out. I have things mapped to command T, like if I add a lot of white space here and get the indentation off, if I hit command T, you'll see that it like fixes that auto indent stuff for me. So I use stuff like that. Atom also, I believe, if I start doing like, what's a common JavaScript function? Like set time out, maybe it's, but it knows sort of different variables I have and kind of tries to autocomplete things for me. So, you know, there's no one answer to this question. This is just Atom. Processing IDE has a lot of features in this direction with autocomplete and that sort of thing. And Sublime as a Sublime Text, another text editor I've used a lot. Okay. So I'm looking, sorry, more. I'm catching up on the questions. When can I show off my work if I code some awesome evolution stuff? Simic asks. So I'm not sure exactly what you mean by this, but I would be thrilled to have people come on as guests, and you can Skype in and even like show a project through screen sharing, or if it's online, I can go to the URL, or you can simply send it to me, and maybe I'll do a session where like I take viewer submissions and show the projects. If that's what you mean, I would be happy to do that. Maybe file a GitHub issue on Rainbow Topics to open this discussion. I can think about ways of organizing that. Can we have the design of your t-shirts to make there somewhere where shipping is easier or for other countries, or will you make some for other countries? Yes. So Gabriel asked, I am not doing the t-shirt stuff as an income generating thing. I mean, I'm not opposed to that either, but I'm happy to share with you the design files, and if anybody wants to, or if you want to just suggest to me a service that you think would be good for where you live, I will be happy to upload the design files and make them available. So just be in touch. I think Twitter is probably a good way to be in touch with me about that. Taylor writes, hey Dan, interested in using game engines as a sub-series, perhaps Unity? I am interested in that. I have just like infinitely long list of stuff to get to, and to be honest, I don't know Unity, so I'd have to kind of like learn it a little bit. Although people do enjoy some of my videos where like, I've never used this before, but I'm gonna make a tutorial with it. Just figure it out as I go. Unity is probably a bit sophisticated for that. So, but this goes, I'm definitely interested in having guests, and I've been in touch with some folks do sort of guest tutorial series, and so Unity could be a topic for that. I am generally more inclined to use open source free environments, but I'm certainly not opposed to using other environments. Something which is not open source and free, I've been wanting to do tutorials. My kids are really into Minecraft, and I've been playing around with Computercraft and different like programming things with Minecraft. So I would love to command blocks. I would love to do some stuff with that. It's something that I've been thinking about, but I just constantly haven't gotten the time to prepare for it because I'm so busy just trying to do these sessions with stuff that I already know. Connect, can you please do something with can you please do something with the Connect plus Animata plus OSC control? I do hope to do many more Connect videos. I have a few, but I've barely scratched the surface, and I haven't done anything with the Microsoft SDK and skeleton tracking, which on Windows you can do, so I would like to do that. The Raspberry Blonde writes, I did some stuff on Perlin noise terrain. I added lighting and a day-night cycle, and I finished it, and I'll tweet you a video plus code, but making a video isn't working yet. If I can help you with making a video out of it, please let me know. Tweet me, and I would love to feature that. Yep. Viewer submission. People like the viewer submission idea. When are the genetic algorithms tutorial coming? When are they coming out? Ask Akash. I don't know if Mathieu is in the chat. He would have a good answer for that question, but my expectation is that I'll start releasing them beginning of next week. What about Blender? Blender scripting, that sounds exciting. Blender, it's getting a huge update soon. What's getting a huge update soon, Alvaro? Were you talking about Minecraft? Python scripting, yeah. So all these are great ideas. I got to the end of those questions, and I can put on my, oh. Wait, what happened here? What happened to my music? That's weird. I've lost my music. Not that that really matters. I wonder if because I'm using a free trial of this software, which I think I'm going to purchase, even though I'm terrible at using it. Another thing I'll mention while I'm here, for those of you who might be interested in contributing to the YouTube channel, each video, I've now opened up a way for you to contribute captions, and I'm going to go check this right now. So I'm going under my admin tools, and I'm going to go under community, and you can see here I'm going to look at manage subtitles. So you can see, oh, this is actually, so I don't know who submitted this, coding challenge number 28 in Spanish. Hold on, sorry. Somebody submitted Spanish subtitles to coding challenge number 28. There already were Spanish subtitles. So when I went to accept these, it said it was going to overwrite the previous ones. And I'm not a native Spanish speaker, so I couldn't tell if one was better than the other. So I'm just leaving those there. You can see these are all the published ones. But I encourage any of you who feel so inclined, I would love to have more submissions of English or other language of subtitles for any of the videos online. And you can do that through the YouTube software itself. Arduino is something that I definitely would consider as a topic at some point in the future. Let's see. I don't know why I lost the music there, but it's back. So I got 3 minutes again. See if there are any more questions. I also want to, there's more information in the Rainbow Captions GitHub repository, I believe. Oops. Let's find this. Rainbow closed captions. So here's some links to where you can contribute captions. You can also do this through Amara. And then it's my desire to have all of the captions here on GitHub as like open source files, but I haven't had the time to kind of like download them from YouTube and submit them. Yes, Wolf app APB at Chrome extensions. So something that I'll be doing in the fall that I'm very excited about is I have a course that I teach at ITP. These are all the topics, all in JavaScript: strings, regular expression, data and APIs, Chrome extensions, Twitter bots, closures, Markov chains, all sorts of stuff about text, algorithms with text and language in JavaScript. And I'm going to be making videos on all these topics starting in September along with the course. And if you subscribe to the Patreon, what I'm going to do in the Slack channel is have people do the assignments and submit them and have a discussion. So kind of have an online version of the course kind of going in the Slack channel as well. Everybody is asking about creating a ray tracer. Is that like a assignment that you get in a computer science class or something? You know, mostly I'm more inclined to do stuff to not focus on things that, it's an interesting topic and I probably could get something out of it. I honestly don't, I've never done this myself and don't know how off the top of my head. You know, mostly I'm more inclined to look at like WebGL environments and just sort of do experiments with kind of existing 3D environments rather than learn how to like program one from scratch, although it's kind of interesting to think about as well. But I could be convinced otherwise. Akash asks, tell us something about your work in university. See if I pause the music. Keeps going. Since you asked, I teach at a program called ITP. It's part of New York University, Tisch School of the Arts. It is a graduate program, a 2-year master's program. And students work on all variety of creative projects and playful experiments, from art to commercial stuff to design to research and writing to all sorts of things. And I encourage you to check out the website and look at the different courses. And I teach there. In the fall, I'll be teaching 3 classes. So I'll be a bit busier, but I'm hoping to be able to keep these live streams at least once per week. I'm trying to do them twice a week right now because I'll also be away for 2 weeks in August. And I'm committed to trying to have 4 live streams per month, which is once per week. And I think if I think I've done at least 4 already in July, and if I get a couple more next, I want to try to get to 8 by the end of next week, because in August I'm going to be on hiatus for a little bit. Oh, shaders, 100%. Matthew Caney, who is working on a shader API for P5JS itself. So I'm definitely planning on doing some shader tutorials once there is a shaders available for P5JS. And then I might also look at processing shaders. Why am I at sfpc.io? So some of you I forgot should mention, SFPC is an independent artist-run school called the School for Poetic Computation. They run programs. They're running a 10-week program right now. They run 2-week programs, just weekend workshops, all sorts of types of things. And I am doing a residency here, and I set up a recording studio here. So I'm kind of collaborating with them. They're not too far away from ITP. I can go back and forth. So I hope to be able to continue to collaborate with SFPC. Since I'm talking about all the things that I work on, I'll also mention the Processing Foundation. So I am an administrator and director of the Processing Foundation, which is a nonprofit organization committed to promoting software literacy and making open source software more inclusive and accessible to all audiences. And we're nonprofit. We have a lot of different programs, and I do a lot of work around education with processing as well. Data visual, I have a Cistern asked a data visualization tutorial. Go look in my P5JS data playlist. I have about 8 or 9 or 10 tutorials there. There's definitely a lot more that I could do in the visualization sense, but I do plan on doing more of that. I want to do a mapping tutorial. Pokemon Go mapping, yes. Thomas, thanks for finally making it to a live stream. I'm sorry this is the end. There's about 10 seconds left before I say goodbye. And I will be back next week. I did 2 this week, but stay tuned. A lot of the videos, the edited versions out of these live streams from this week and last week, I think, are still coming. I've got a lot coming down the pipeline. So stay in touch on Twitter and in the YouTube comments, and I look forward to hearing from you and seeing please, when you make something from one of my tutorials, it brings me great pleasure and joy to see it, so please share it with me. Okay, goodbye everyone. Enjoy the rest of your day or night. Stay warm, stay friendly. Go give a friend a hug, a high five, whatever you're comfortable with. Put something nice out into the world beyond just writing code, or put something nice out into the world with your code. And I hope to see you all soon again on another live stream. Okay? Goodbye. Finding the mouse here to actually press stop. 2.5 hours. That's the length of a course that I teach at ITP. So I feel like it's a good length for this. Okay, goodbye.